Hi, good morning, boys and girls. I hope you and your families are doing really well. We miss each and every one of you, but for now, we're going to get through this confusing and challenging time together. All of your science teachers, me, Miss Messina, Miss Cabrera, Miss Levin, Miss Hidalgo, and Miss Schwartz, and Miss Viola are going to be with you all the way through this. We're going to be working hard all together, and we're going to be very successful as long as you put in your best effort and work really hard with us. You will do great. So last week you each received a hard copy of a review packet that was put together for you for third quarter. That packet was intended for you to review and to help reinforce your learning for a short period of time. But now that we hear that we're going to be working at home for a little bit of an extended time, we want to move ahead into our chemistry unit. And luckily for you, chemistry could be a lot of fun. So your teachers and I are putting together lots of different activities, assignments, videos, and everything to try to make this experience joyful for you. If you don't have any of these materials at home, when we are doing some of the lab activities with you, it's okay, because you can just watch some of our demonstrations. Okay, and here we go.
What is matter? So boys and girls, everything in the universe is either matter or energy. Matter, by definition, is anything that has mass and takes up space. Can you think of a few examples of what is matter? Okay, well, that's what we're going to investigate. So now that you've thought of a few examples of what is matter, we're going to investigate, how is water matter? How do you know water is matter?
Does water take up space?
Hi, so yes, water does have volume and water has mass. You can see from the bottle of water that water is in the bottle, but you can see that the shape changes. This is one of the properties of matter and one of the properties of water. Today, what we're going to be investigating are other properties of water. We're going to see how the molecules which make up matter act with each other.
All right, so what you're going to need to do for today is you're going to need to gather a few materials. I'm going to tell you what the materials are. If you have them at home and you want to participate with us, that sounds like a lot of fun. So you can do that. And after I tell you the materials, you can pause the video and get your materials and then continue the video. If you don't have the materials, it's perfectly fine. You can just watch us and imagine in your head that you're doing it as well. Okay, so what you're going to need is, the first thing you're going to need is the activity sheet. So you have to click on the bottom of Schoology and download the activity sheet. If you don't know how to fill out the activity sheet, we have posted a video for you on how to fill out the activity sheet. So there's many different ways you can do it. So you can follow the video, or you can just download the activity sheet and then screenshot it and use the photo editing and use your finger to write on it and screenshot it again before you submit it. Many different ways to do it. So we have posted that for you. So, and I think you may have done that before. The other things you need for today's lab, besides the activity sheet, is you're going to need a glass of water, a butter knife or a fork or something like that, and either a piece of wax paper, a paper plate, or really any other plate. It doesn't really matter that much. So pause the video and come back when you have your materials, or if you don't want to do it with us, you can just follow along. Okay, so what we're going to do is we're going to look at a drop of water and see how a drop of water holds together. So take your knife, and what you want to do is you want to take that knife and dip it in, dip it in the water. We're all going to learn here together. So, you know, if you're having trouble and you're having trouble with the technology, it's okay. We're all figuring it out together, and we're going to go slow. So it's no problem. So you're going to take the knife and get water on it, and I want you to observe carefully the water. Do you see how the water droplets Do they hold together? So what I want you to do is I want you to see what is going on. How long can you make the droplet hang off the end of the knife or your fork or whatever else you have? And so what I'm going to do is I want you to observe that. Why is that? So what we're going to do, see how far you can make the drop hang off the end of the dropper or the knife or whatever else you're using, a fork or whatever you happen to have at home. Can you have the drop hang off the knife? Well, mine's a knife, but whatever you have. See how it's hanging there? Do you see it? How long can it hold there without it falling off? And why is that water hangs off the knife and doesn't just pour off? So now what I want you to do is I want you to take, let's see, can you see the water on there? I'm not sure you can. So what you want to do is you want to put a bunch of drops of water on the plate together to make like a medium-sized drop. I actually have a pretty big drop on there. I don't know if you can see it. Hold on. So once you can see the medium-sized drop on your piece, so put a couple drops together to make a medium-sized piece. Then tilt it, and what do you notice with the drops, with the big drop? Does it stay together? Does it come apart? Make your scientific observations. Tilt the plate or your wax paper or whatever you have and see if you can make that drop move around. What do you notice happens? Then what I want you to do, I'm going to put it in the middle so maybe you can see it better. Now what I want you to do is I want you to take the knife and I want you to move that drop around. What do you notice happens? Does the water stay together or does it separate? Mine seems to be staying together. Isn't that interesting? Can you use the popsicle? Can you use the knife or your fork or whatever you have? Can you use that to separate the water into pieces? Is it easy to separate or is it not so easy to separate? You probably can get it to separate once you try a little bit, but then when you push it back together, is it easier to push it together or is it easier to keep it apart? Okay, so what I'd like you to do is I'd like you to write your observations now on your activity sheet. The first one is when you squeeze the drop of water out of the dropper, which we didn't really use the dropper, but when you put the drops of water on your plate, did the water break apart or did it hold together? When you tilted the plate, did the drops fall apart or stay together? They mostly stayed together. Some of it came apart a little bit, but mostly the drops stayed together. When you tried to split your drop, did it separate easily? Or was it kind of hard to separate it? Do you think it wanted to stay together or it wanted to come apart more? And what happened when you had two tiny drops and they touched each other? So if I have my two smaller drops and they touch each other, what is going to happen? I'd like you now to stop the video and I'd like you to answer some of the questions on the activity sheet and come back to me for the discussion and the second part of this lesson. So go ahead and pause right now and I will be back with you when you're finished answering some of the questions.